Okay, so this is our Properties of Quadrilaterals lesson. We learned how to find the number of degrees in any polygon, and we learned that in a quadrilateral there are 360 degrees. So we're moving on from there. Review from last time, divide this into triangles using diagonals that start at point A. Well, here's point A. I can't go to B because it's right next door. I have to go to C, D, E, F, G, and H, even though it makes this teeny tiny little triangle here. Alright, so how many degrees do the interior angles of this figure have? Well, there are 1, 2, 3, 4, 5, 6, 7 triangles. So 180 for each triangle times 7 triangles is 0, 56, 7 and 5 is 12, 1,260 degrees total. Alright, and this one says, how many degrees do the interior angles of this figure have? Well, I would have one diagonal, 2 triangles. 2 times 180 is 360, like I already mentioned. So we can find the missing angle by taking what we have and subtracting from 360. Well, 105 and 45 makes 150. And 150 plus 75 makes 225. And 360 minus 225 is 135. And it's obtuse, so that makes sense. Although it's not drawn to scale, so you can't always count on that. Okay, so only one objective today. We're going to categorize quadrilaterals based on their side and angle measurements. The quiz is our next class, so make sure you're studying. The review packet is due on that day. Remember the review packet, if you count the front as one page and the back as another page, it's 6 pages. You had a week to do it, which should have been enough time, but if you put it off, then you're going to have a lot of work to do. But there is a video to help you, so get that done. We are making a flip book of quadrilaterals, so I should already have it put together for my biggest classes at least, because I don't want to, it takes a lot of time to try and pass the stapler around and all of that mess, so all you got to do is put your name, team, and period on it, and then we get started. We flip to the vocabulary page and we fill in our vocabulary. If things that have the same measurement, size, shape, degrees, etc. are congruent, so that is the word that belongs in this blank, congruent, same measurement. To cut something into 2 congruent or equal pieces is to bisect. It's usually used with a line that bisects an angle or another line. A line from one vertex to another vertex of a polygon is a diagonal. Lines on the same plane that never touch are parallel lines. They are always exactly the same distance apart. Angles that share a side but not a vertex, or sides that share an endpoint, are consecutive, one after the other. So for example, in a square, we'll call it a quadrilateral since it's ugly, these are consecutive sides. These are consecutive sides, these are consecutive sides, and these are consecutive sides. They're touching, but only at one point. And consecutive angles are this angle and this angle. They share one side, but a different vertex. Alright, first we talk about a quadrilateral. This is the broadest part of our flowchart or umbrella for quadrilaterals. It is a closed figure with 4 straight sides. They do have to be straight. If they curve, it is no longer a quadrilateral. Its interior angles have a sum of 360 degrees. And quadrilateral is a very broad term. It includes everything from trapezoids to squares. We have a little bit of practice in here. This is something that might be easier to come back to after we've looked at all of the different shapes. So we'll do that first. Alright, next is a trapezoid. A trapezoid has one pair of parallel sides, and we mark that like this. These two sides are parallel. The little, turning them into this little arrow thing means that those are parallel. And isosceles trapezoid has one pair of congruent, non-parallel sides. So this one happens to be isosceles. Those are congruent, non-parallel sides. They're the same size, but they are not parallel because obviously they would touch if they kept going this way. Some mathematicians claim that a parallelogram is a special type of trapezoid. Most, though, argue that a trapezoid has exactly one set of parallel sides, so it has its own special category. So here are some examples of trapezoids. This is, there are the two parallel sides, parallel, parallel. This one is isosceles, this one is not. Normal trapezoid, isosceles trapezoid, you can see the difference between when they have congruent sides and non-congruent sides. Next on our list is a kite. Kite has two pairs of consecutive sides. Two pairs of consecutive sides that are congruent. We mark that like this. These sides are congruent, they're the same length, and these sides are congruent, they're the same length, and they're consecutive because they share a point. They're only touching at that one point. And these are consecutive, they're only touching at this point. They have at least one set of congruent opposite angles. So this angle is congruent to this angle. Diagonals are perpendicular to each other. Perpendicular means they form right angles. So if I draw my diagonals from vertex to vertex, like this, they make right angles. A kite is a special type of quadrilateral. A rhombus is a special type of kite. Here are some more kites. And you can see a kite is kind of like the kite that you fly. Got its name because it looks like a kite. That's how they're shaped, usually. Alright, a parallelogram. So far we've had parallelogram, kite, and trapezoid are all separate figures that branch down from from quadrilateral. So they all have four sides and 360 degrees, but then they have different properties. Parallelogram has two pairs of sides that are both parallel and congruent. And we mark that like this. Congruent, parallel. Opposite angles are congruent. So that means that this angle and this angle are congruent, and this angle and this angle are congruent. Consecutive angles are supplementary. That means that these two angles make 180 degrees, these two make 180 degrees, these two make 180 degrees, and these two make 180 degrees. Diagonals bisect each other. Remember, bisect means to cut into two equal pieces. So diagonal on a parallelogram cuts the other diagonal in half. So it's the same length on this side as it is on this side. You draw that like this. 1, 2, 3, congruent to 1, 2, 3. 1, 2, 3, 4, congruent to 1, 2, 3, 4. Sorry. With just one angle, we can find all the other angles in a parallelogram. Subtract the given angle from 180 degrees, because it's supplementary to the consecutive angle. The opposite angle is congruent to the given angle. So for example, if this is 70 degrees, then this has to be 110, because 70 plus 110 makes 180. This has to make 70 because it's opposite, and this has to be 110 because it's opposite of this one. So here's some practice. We have 118 degrees. We can find the consecutive angle by subtracting from 180, and we get 62. And opposite angles are equal, so 62 and 118. Subtract 64 from 180, and you get 116. Opposite angles are congruent. Subtract 122 from 180, and you get 58. Opposite angles are congruent. And then if we fill in all of the measurements that we can on this, if this is 55, then this is 55. If this is 77 centimeters, then this is 77 centimeters, because the diagonals bisect each other, so they're equal on each side. The two opposite sides are congruent, so this is 117 centimeters, and this is 66 centimeters. This is a vertical angle, so it's going to also be 58 degrees. This is makes a supplementary angle with 58, so it'd be 122, and there's a vertical angle, 122. 35 and 122 is 157, and 157 minus 180 minus 157 is 23, just like this one. So if this is 23 and 122, 23 and 122, then this is 35. And this is true for all of them. 45, so this will be 45. 45 and 58. You could do this a couple of ways. Add these, and this, and this have to make 180. So add all of these and subtract from 180, or add these two and subtract from 180, which makes sense because 35 and 23 is 58. So 58 and 45 is 103, so that would be 77 degrees, so this would also have to be 77 degrees. Alright, a rectangle. Two pairs of sides that are both congruent and parallel, just like a parallelogram, because a rectangle is a subdivision of a parallelogram. So, congruent and parallel. All angles are congruent. All angles are 90 degrees. So 90 degree angle, 90 degree angle, 90 degree angle, and 90 degree angle. Diagonals bisect each other, just like with the parallelogram, because this is a parallelogram. It's just a special type of parallelogram. So I draw my diagonals, and they bisect. A rectangle is a special type of parallelogram, and a square is a special type of rectangle. Opposite angles are still congruent because they are all 90 degrees. All angles still up to 360 degrees, and consecutive angles are still supplementary, meaning they add up to 180 degrees because 90 plus 90 equals 180. Alright, a rhombus is a different special type of parallelogram. It has two pairs of parallel sides. This This is parallel. This is parallel. All sides are congruent. So congruent, 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 congruent. Diagonals bisect the angles. Like this. So that means that this is equal to this, and this is equal to this. Diagonals are perpendicular to each other because a rhombus is a special type of kite. And a kite has perpendicular bisecting angles. I mean, not bisecting, perpendicular diagonals. The diagonals form four congruent right triangles. Because they all have a side this length, a side this length, and a side this length with a 90-degree angle here. A rhombus is a special type of parallelogram and a special type of kite, and a square is a special type of rhombus. Just like with a parallelogram, you can find all angles of a rhombus with just one known angle. Subtract the known angle from 180 degrees to find the consecutive angles. So if this was 68, I would do 180 minus 68 is 112, and that'd be this angle, and this angle, and this would be 68. Right, a square has two pairs of parallel sides. So parallel, parallel. All sides are congruent. This side, this side, this side, and this side. All angles are 90 degrees. And diagonals bisect the angles. That means that it makes equal angles. So that means that this angle is equal to this angle is equal to this angle, and so on and so forth. And they are all equal because they are splitting a 90-degree angle in half, so they are all 45-degree angles. Diagonals are perpendicular to each other, so they make 90-degree angles. And of course they also bisect each other, and they're actually all the same length, like this, because they make isosceles. Four congruent isosceles right triangles. So all of these triangles are exactly the same, and they're all isosceles. The square is a special type of rhombus and a special type of rectangle. It happens when you combine the properties of each of those two shapes, and it's as specific as you can get with a quadrilateral, because a square is a parallelogram, it's a kite, it's a rectangle, it's a rhombus. The only thing it's not that we've covered is it's not a trapezoid. Here's our quadrilateral flowchart, which just shows all of these characteristics in one flowchart. So you can see it starts with quadrilateral, goes down to kite, parallelogram, and trapezoid. They included isosceles trapezoid. Parallelogram, which splits into rectangle and rhombus, and kite joins in on the rhombus, and rectangle and rhombus both go down to a square. So this is an interesting flowchart, but this is just all the stuff that we just talked about. Alright, so here's some special properties that we went over. Because every quadrilateral has interior angles that sum to 360 degrees, If we know the measure of 3 angles, we can find the measure of the 4th. So you add all the angles and subtract from 360. So 360 minus 78 minus 127 minus 43 is 112 degrees for that missing angle there. I'm going to skip those because we've done several of those. Because every parallelogram has opposite angles that are congruent. We know that if we know the measure of one angle, we can find all of the rest, so we just have a little bit of extra practice here. If this is 50 degrees, we're trying to prove this right now. A parallelogram is a quadrilateral with 2 pairs of congruent parallel sides. So if we split it into 2 triangles, we create congruent triangles, because this side is equal to this side is equal to this side, and this side is the same, so it has to be the same for both. So these are congruent triangles. We just have to like rotate it in order to line it up with its pair. This proves that the top right angle is also 50 degrees, because if they're the same triangle and these sides make a 50-degree angle here, then they also make a 50-degree angle here. So now we know that opposite angles are congruent. We proved it. If these opposite angles are congruent, then these opposite angles are also congruent, because this angle is the same as this angle, and this angle is the same as this angle. So this plus this is the same as this plus this. We can also figure out what the measure of those angles are, because 50 plus 50 is 100, and 360 for the whole shape minus 100 that we know is 260 left over. But it has to be split evenly between these 2 angles because they're the same. So half of 260 is 130, so each of these is 130 degrees. This also proves that consecutive or adjacent angles are supplementary, because 130 plus 50 equals 180. They're always going to be supplementary like that. Whew. So to find the rest of the angles in a parallelogram, we mark the opposite angle with the same measurement, subtract the given angle measurement from 180 degrees, then mark the remaining angles with their answer. So first I say this has to be 145. Then I say 880 minus 145 is 35. So this has to be 35, and this has to be 35. Here, 120, the opposite one is the same. 180 minus 120 is 60, and opposite angle is the same. Then we have some practice. Classifying. It says put the most specific name for each figure. So this is a parallelogram, because we see all of the parallel sides, but they're different lengths. This is a trapezoid, 1 pair of parallel sides. This is a rectangle, because it has 2 congruent pairs and all right angles. This is a kite, because it has consecutive congruent sides. This is just a quadrilateral. This is a rhombus, because it has all equal sides, but not 90-degree angles. This is a rectangle. Opposite sides are congruent, 90-degree angles. This is, all sides are congruent. Opposite angles are congruent, so this is a rhombus, because if I marked it, it would look like this. Parallel, 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 parallel. Opposite sides are congruent. Opposite angles are congruent. This is a parallelogram. And then this is congruent, congruent. One set of opposite and equal angles. That's a kite. Okay, this has no equal sides, no equal anything, nothing parallel, so this is just a quadrilateral. And this has 2 opposite and equal sides, so 1 pair. This would have to be an isosceles, to be more specific, an isosceles trapezoid. Right, all possible names for each figure. Well, this is a quadrilateral. It is a parallelogram. It is a rhombus. It is a rectangle. It is a kite, and it is a square. Whew, that's a lot. I'm going to have to start abbreviating. This is a quadrilateral. I'm going to put Q for quadrilateral. A parallelogram. That's par for parallelogram. That's all I know about that one. This is all equal sides, so it has to be a quadrilateral, and a rhombus, RH for rhombus, and a kite, because a rhombus is a kite, and a parallelogram, because a rhombus is a parallelogram. This is a trapezoid and a quadrilateral. Trap. This is a kite, and because it's a kite, it is also a quadrilateral. This is a quadrilateral, a parallelogram, a rectangle. And that's all I know about that one. And that's all the practice. So we have our quiz next class. Make sure that you studied. The quiz is 11 questions, 15 points. There are 2 BCRs. It's going to cover everything with angles and polygons. It'll have a question about a parallelogram, so you have to understand that opposite angles are congruent, and that if you have one angle, you can find any of the other angles in a parallelogram. You have to be able to find the missing angle in a square or a triangle. You have to be able to find supplementary, complementary, vertical angle pairs. And that's the bulk of it. The study packet should have helped. I think the hardest question on the test that wasn't covered very much in the study packet is the parallelogram question. So if you understand that, then hopefully you'll be okay. So good luck. I know you've got this.